Hello everyone. Today we'll be looking at data visualization. In fact, we'll be going into what we call the EDA. Now, the EDA means explanatory data analysis. So now we'll be using what we call some libraries in Python. So we have what we call Seaborn and we have what we call Plotly. Now, we're talking about Plotly. So in Plotly, Plotly is called a Python data visualization. It helps us to view data, okay, in terms of diagrams. Now, what is Plotly? Plotly is an open source library. When something is open source, it means it's acceptable to everyone. All right. So we're using Plotly today to visualize a data set. All right. Now, if you want to run it using Jupyter or if you're using the VS Code, you have to first install the library. Now, we use what we call the pimp install. The full meaning of pimp means the package installer for Python. So it's a prompt command we write to the system, which helps us to install the library called Plotly. Now, when you do that, then you run. Then if you want to use it, let's say you want to use a library, it is important that you use the import command. So I will uncomment this. So you can see import plotly.express. So when you say import plotly.express, then indirectly you are saying you want to import Plotly. So like I said, it's an open source Python language that we use to display data. That's data visualization. Sorry. Then EDA. Now the definition of EDA means we want to add meaning of EDA, explanatory data analysis. Now what this means is that we want to identify patterns, hidden patterns, trends, correlations, relationships using Python library called Plotly. Now, import plotly.express as px. Remember, this is the aliases representing px. Okay, when I do this, then I want to run, I'll use my shift enter. Okay, so I'll run this. You can see it's taking time. Now it's done installing. Now, the next thing I'm going to do now is that I'm going to uncomment this information here. So what I want to do now is that I want to access those attributes that are already embedded in Plotly. If you want to know what's attributes, you need to go to our previous video where we talk about modules and conditional statements. All right. So now if I run this again, now you can see we have various attributes embedded in Plotly. Now the next thing we are going to use now is that in Plotly we have what we call inbuilt data set, meaning that there's this data set that is already embedded in the Plotly in the library called Plotly. So I'll uncomment this. So what I did now was df is equals to px. You can see px dot data. If you check, you will see data. Okay, this is the data. Then dot tips. Dot tips is the name of the data set embedded in Plotly. So if I run this now, that's to display, you will see that we have the total bill, that's the amount of money spent by individuals that went to a particular restaurant. Then the tip, that means in the correct way, what it means is that you gave extra money to, you were satisfied with the performance. So you use it as a tip to tell them, okay, thank you. Okay. Then we have the sex, as the gender, smoke, if they smoke or not, then the day, the time, and the size. So this displays all the information. You can see 244 rows, 7 columns. Now, the next thing I want to do now is I want to display in terms of the info. When I mean info, it means I want to see in terms of data type and the index numbers. So you can see, if I run this now, control, the shift enter, and you can see we have the data column. So we have 7 columns. Then you can see in terms of the data type, D type means a data type. So float 64, objects and integers. So you can see the entry is 244, meaning that an index of 0 to 243. Now, the next one we're going to do now is we want to, the next code holds, we want to check if there are missing values or not. It's very, very important for you to check your missing values. So I'll comment this. So when I comment this now, I use the control question mark to uncomment my code. So if I run this now, you can see that our data is clean. It's no means are they, is no means are they missing values, then summation of those missing values. All right. Now, the next one we are going to do now is that there's a code here that said pip install NB format. Now, NB format helps or aids us to visualize our diagram. Plotly.express is not only enough. We also need NB format. So the first one we want to do now is we want to do the pie chart. Now, the pie chart helps us to display all the values in all the values of a portion all over 100, okay, in terms of the percentage format. So if I run this now, That's uncomment this. So what we have here is now is the px. Remember, that's the presentation of plotly.express dot pi. Pi means the pie chart. Then the data, then the parameters, which are numbers for smokers, the values, and the type. So we want to check in terms of the smokers and the tips. Okay. So if we run this now, you can see we have in terms of ratio, okay, ratios of people who smoke and who don't smoke. So you can see people who smoke but give tip, yes, and people who don't smoke but they still give tip. All right. So you can see in the application now we are going to identify that we have more people who don't smoke but give tip compared to people who smoke that give tip, with a percentage of 61.8% and 38.2%. All right. Now the next one we want to look at now is the histogram. All right, histogram. So uncomment my code. Now we have what we call the histogram. Now the histogram helps us to display values. All right, distributions of values. So that's what we're going to do. So we have the df, then x is the parameter. That means we want to see in terms of total view the numbers of beans, in terms of the length of the bars, and the title. So if I run this now, you can see that we have the total distribution, okay, in terms of the total amount of money that was being spent. All right, now we have this. Now the next one we are going to do is the stacked column chart. Now the stacked column chart helps us to show in terms of the proportion of values, but in terms of range of categories. Okay, we're looking at just one in terms of different categories. That's when we use in terms of the stacked histogram. So I want to uncomment this information. So you can see the total bill by the gender. So we want to know in terms of which gender spend more or who earns more, okay? In terms of gender. So if I run this again, you can see total bill by the sex, meaning gender. So you can see that the male tends to spend more on the total bill compared to the female. So you can see how we have been able to use diagrams to identify hidden patterns that we won't be able to observe from our first data that we do here. Okay, so that's the benefit of using this. Now the next one we are going to use is the box chart. Now the box chart, basically it helps us to show in terms of the upper bound, the lower bound, and also helps us to identify what we call outliers. Now outliers means extreme values. Those are values that do not fall within a particular range. All right, that's the meaning of outliers. So if I uncomment this, and you can see the total bill by the gender. So we want to see in terms of the extreme values that are being spent for male and female. So when I run this now and I scroll down, you can see the extreme values. You can see the normal range they spend in terms of the from here. If I take my cursor here, so you see this the lower fence and the upper fence. So the lower fence, upper fence means the normal range. Then you can see that the dots we have here are the extreme values. So you can see that the male tends to spend more abnormally compared to the female. All right. Now, the next one we are going to do is the funnel chart. Okay, the funnel. Now, the funnel helps us to show in terms of progressions. All right. So what I have here, I will explain my code. Let me uncomment it. Is I have a variable which I grouped, use the df, and I grouped it by the day. Okay, and I got the sum. So what I did was that, okay, give me all the day and the total sum of total bills spent on each day. Now, the next one I did was to sort it. So I sorted in terms of the descending order, meaning that I started from the highest total bill to the lowest total bill. Then I was able to display it using the funnel. Okay, so when I run this now, you will see it's going to display it in terms of in a descending order, not an ascending order. That's why you see ascending equals to false. So you can see, so the highest they spend in a particular day is Saturday, Sunday, Thursday, and Friday. All right, that's for the funnel chart. Now, the next one we want to look at now is the tree map. Now, the tree map helps us to display information in terms of rectangles. Okay, rectangles. So we want to see, and it also helps us to display hierarchical data. Meaning, when something is hierarchical, it means it has to be in a particular order. Okay, a particular order that has to be preserved. So when I run this now, you will see that we have them in terms of different orders. So according to Saturday, which we found out in our funnel, that Saturday was the highest. Now you can see them that we have in terms of rectangles. Okay. Now the bigger the rectangles, it is proportionate to the values assigned to that Saturday. Okay. So if we click on Saturday, you can see we are only visualizing all that has to do on Saturday. So you can see for male, female, all the information. If I want to go back, I click on Saturday again. See, click on Sunday, and Friday, you can see all the information as regarding Friday. So that's for the tree map. So it helps us to display hierarchical data using the nested rectangle. Meaning when something is nested, it means a rectangle inside a rectangle. You can see they are all rectangles. Now, the next one we want to look at now is in terms of the bar chart. Now, the bar chart helps us to display in terms of categorical values. Now, we want to see in terms of the gender by the total bill using the bar chart, how it looks like. So if I run this now, you see we have in terms of the male and female. So in summary now, what we have gotten using the bar chart is that we know that the male spends more than the female using the bar chart. Okay, so all these diagrams are all embedded in Plotly. Okay, Plotly is the 2D. That means when something is 2D, it means it shows us in terms of the values. You can see we have the female and the total bill. That's for the total bill. That's for the bar chart. Now, the next one is we are going to look at scattered charts. Now, the scattered chart helps us to show in terms of the correlation. All right, is it positive correlation? Is it negative correlation? So you can see the scatter chart. So the scatter chart dot scatter, you see the px dot scatter, then you call the name of the data set, that's df, then you pass in those columns that are already inside the df. That's how we pass them to the right parameters and a title. So when I show this now, you can see between the total PIP and total bill. So there's a positive correlation between total bill and tip, meaning that the more we spend more on tip, the more we spend more on total bill, we tend to spend more on tip. That's the interpretation. Now, the next one we're going to look at is what we call the sunburst. Sunburst. Now, we use the sunburst to display hierarchical data using what we call the concentric ring. So now you can see, now when I run this, now you can see in terms of the rectangle. So when I click on one, see, it shows us the information in terms of ring. So is like the tree map, but tree map was nested rectangles. But here now we're doing in terms of the concentric ring. So if we check the concentric ring inside, the inner ring, the inner circle inside, which is called the ring, has the higher value compared to the outer ring we have here. So you can see for different of them, Thursdays, Saturdays, Saturday, and Friday, they will all open. Okay. Now, the next one we want to do now is we want to perform what we call an animation plot. Now, when we say an animation plot, it means we want to show the plot behavior over a particular period of time. So when you say animation in terms of like a video, but it's going to be in terms of a diagram. So what I'm going to do now is that I'm going to uncomment this information here. So I passed in a variable to df1 called the data graph. Okay, data graph. So data graph, so the data dot gapminder. So gapminder holds an information we want to use. Okay, so when I run this now, it's going to display all the information. So you can see in terms of country, continent, year, life expectancy, population, GDP per capita, the abbreviation, and in terms of numbers. All right, and the total rows we have is 1004 rows, 8 columns. Okay, so the next one we have here now is where we write our code. So when I uncomment this now, you see I'm using a scatter chart. So I call the df1. All right, then I say I want to see the GDP versus the life expectancy, then the animation in terms of the year and country, then the size is going to be in terms of population, then continent is going to have its own color. So all these are parameters in terms of the size and the title. So if I run this now, look at the outcome. So this is total information, log underscore x equals to true. That's the total information. If you scroll down now, you see we have like a video. So this in terms of the years. So the more when we play this, the year is going to move, and we are going to see the reaction in terms of population according to each country. Okay, according to each country. So if you scroll down, you can see in terms the colors are attributed to each countries, to each continent. Sorry, each continent, not countries. So if I play this now, you see the behavior as the year moves. So you see the population begins to change. Okay, so you can see in terms of different countries until get 2007. Okay, so we are dealing with year, the population, GDP over time. So you can see the behavior using the animation plots. All right. Then lastly, we also have what we call the sum plot. Now, the sum plot helps us to display two diagrams together. So for you to use the sum plot, you have to use import the plotly.graph object as go. Then from the plotly.subplot, we import make underscore subplot. So we want to use make underscore subplot because the subplot we want to do two plots. So I'll run this code. Now I'm going to comment the next one. So what I have here now is that I created a variable called the df underscore year, and the df underscore year is going to hold all the data regarding to a particular year called 2007. You can see the requirements. It's like a conditional statement in using pandas. All right. So if we run this now, you can see I have all the informations, but they must have the year must be 2007. Anything out of 2007, I don't want it. So that's the selection I just made. Now, the next one I did here now is I'll comment it. So I grouped the country in terms of the population by the sum. That's what I did here. So you can see group by the country dot the aggregate of the sum population as regarding 2007. Then the next variable I have here is now is that I sorted that information rating from the highest population to the lowest population. That's why you see df underscore pop dot sort. Then open bracket by is the parameter for the population, which is POP, short-term abbreviation, then the ascending force. Now, what I did here now was that I created a variable and I assigned each of them for the top. Now, we used header. That means I want to see the top 5 highest population, then bottom the top lowest population in the countries. All right. So if I uncomment this as well and I run this now, you will see. Okay, I have not run the first one. So I have to go back to run this code. So you can see the last 5 countries with the lowest population as regarding 2007. Now, the next one I'm going to do now is I will comment this. And so what we'll do now here now is that I use the make plots row 1, column 2, and title last 5, first 5. Okay, so I'll be using the diagram to explain. So column 1, row 2, it means this, okay, top 5, then last 5 in terms of their spacing, you can see. Then the next one was the bar, that's the country by the population, one by one, that's the highest. Then the next one was in terms of the bottom, okay, that's what you see, row 1, that's the same row, then column 2, row 1, column 2, column 1. Then the legend, that means show us the legend in terms of parameters equals to true, and the title population comparison. That's what you see, we have population comparison. So you can see the first step 5 countries that performed very well in 2007 is China, India, US, Indonesia, Brazil. And the last 5, you can see those information. So we have come to the end of using the EDA. That means we have come to the end of Plotly using performing EDA analysis. Okay, I hope you're able to understand Plotly, what it's used for and how to use it.